Okay, good morning to our honorable session chair and co-chairperson, presenters, and all the attendees. I welcome you all to global webinar on Engineering, Science and Technology 2020. I would like to introduce our session chairperson, Dr. N. Victor Babu, Head of the Department of Civil Department, Baba Institute of Technology and Sciences, VIZAG. His area of interest and has a vast experience in water resources, waste management, and remote sensing and GIS areas. He has 10 years of experience in industry and 15 years experience in academics. He has guided almost 40 postgraduate students and 3 PhD scholars. He has come up with 43 international and national research publications. Now I come up with our session co-chairperson, Mr. M. Pavan Kumar, Associate Professor of Civil Department. He has guided almost 12 years of experience in academics and industry. He guided more than 40 postgraduate students. Now I would hand over the session to our session chairperson, Dr.
Dear faculty members, research scholars, and other participants from various colleges, good morning, one and all. A warm welcome to the Global Online Conference GWEST 2020 Civil Engineering Paper Presentation Sessions. Myself, Dr. N. Victor Babu, acting as chairperson for this session, and Mr. M. Pavan Kumar will be the session co-chair. Coming to the conference papers, we received more than 40 papers from various countries in the areas of structures, environment, groundwater contamination, solid waste management, GIS, and other areas, out of which 3 were accepted for publication and presentation after undergoing the plagiarism check and reviews. Now I invite Dr. J. Krishnaveni presenters to deliver their presentation.
Happy morning to one and all. I'm happy to share my research work. Experimental study on the impact on anthropogenic activities of ground and surface water. Our team member, Mr. Kamalakannan, myself, and 3 Vanavan and Prakash Kumar has done this research work. So the abstract of our research work is ground and surface water samples have been collected from local areas, and totally 16 samples were collected, and that experimental studies such as pH, electric conductivity, total dissolved solid, total hardness, chloride, alkalinity, and fluoride has been experimentally studied. These tested parameters are compared with that BIS standard parameters and also with anthropogenic agents. Semi-structured interview was conducted and the impact of the pollution on the human health has been assessed. The survey was done by the investigation pertaining to the topic. Their findings and commentations are reviewed. The method that followed in the laboratory for different characteristics of this water from surface and groundwater, that are pHmetry, electric conductivity, total dissolved solid, total hardness, alkalinity, chloride, and fluoride. And the results and discussion that various parameters are compared, this various that characterize, that various parameters have been compared as a result of groundwater sample and also from the surface water sample. So finally, from this, we have concluded that the analysis of the semi-structured interview is clear that more than 50% of people residing around this tank dispose the waste from their households into the tank, which is the prime reason for water quality deterioration. So the quality of water is being deteriorated because of anthropogenic activities. So the contaminants get transported and affects the groundwater quality also. So the groundwater and surface water are not absorbent for drinking water. So these are the main recommendations and studies carried out for this groundwater and surface water by the anthropogenic activities. And various papers are collected program. I owe my sincere thanks to Almighty for my profound gratitude and Principal Dr. R. Magadishwaran, Pune College of Engineering, for granting permission to carry out this work. And I also express my sincere thanks to GWEST 2020, organizing team, lead, coordinators, members of Baba Institute of Technology and Sciences, Visakhapatnam, Andhra Pradesh, India. Thank you. Thank you so much for giving me this opportunity for presenting our paper.
Thank you. Thank you, madam.
Thank you, sir.
Yeah, thank you, madam. You are presenting good paper, but you are not comparing to groundwater. Are you compare groundwater or surface water, madam? You are taking from groundwater samples. That is shallow water table or deep water table?
Both surface water and groundwater, both are collected in that area around Coimbatore, that is in Tamil Nadu.
Madam. Yeah, you are taking groundwater, madam. Groundwater is a shallow water table or a deep water table, madam. You are taking open wells or bore wells.
That in the
because the surface water contaminated due to man-made disturbances like waste is dumping nearby the surface water bodies. The percolate and seepage the leach out. They are contaminated possibility is there, but in case you are taking for a deep water table, bore well sample also contaminated. That is the major disaster for that area for groundwater contamination.
That 16 samples we have collected, sir.
Yeah,
from
ma'am. Yeah, ma'am.
From that, we almost some places are we didn't express our work completely in this project. Just we are analyzing.
Okay, madam. My doubt is you are taking the 16 samples of water from bore wells or shallow water table open wells.
No, that bore wells, sir. Bore well water.
Okay, ma'am. So in deeper area also they are contaminating in that area.
That are mainly influenced by textile effluents.
Yeah, ma'am. Yeah, we are testing for only for drinking water purpose, ma'am.
Sir?
You are
Yes, no, just we are comparing for in the semi-structured interview page.
Okay, thank you, ma'am.
Thank you so much, sir.
Okay, so good morning to one and all. Myself, Sashivendu Lawat. I am working as an assistant professor in the Department of Civil Engineering, Mewar University. And I would like to thank Bhava Institute of Technology to give a chance to present our research paper. So on behalf of myself, Mr. Ubal Al Hassan Musa, he will present our paper, sir.
Okay, no problem.
Before continue, before I continue, I want to start for the content of presentation. Number one, I have the introduction, followed by objectives, then the idea behind the smart manufacturing, and the other key drivers for resilient smart manufacturing, then the basic requirement for the resilience smart manufacturing, also the benefit that we can get from implementing manufacturing in supply chain, and also the nature and the kind of the challenges that we may expect for application. Then second to the last, followed by conclusion, and lastly, but not the least, the recommendation. Okay, so let me start with introductions. Over the past few years, smart manufacturing is one of the most topics between professional and expert in the industrial sector, especially technology and manufacturing industry, especially in Europe and Asia. So basically, Europe, Asia, and the other countries, especially developing countries, has embarked in a competitive race toward the implementation of smart manufacturing in order to be the champion during its emergence. Also, before I continue, I would like to give a brief definition about what actually the smart manufacturing is all about. From so many definitions, I used to grab this definition, which is that it is a process of applying advanced automations, control, simulation, and modeling in production, which will result in safer, quick, efficient, effective, cheaper product or service that meet the demand of the consumer without causing due effect to the habitat and the environment. So therefore, in this definition, we can see that smart manufacturing covers all the requirements that a consumer may need from the supplier or manufacturer for a particular good and the services. So therefore, it is very, very good to implement such innovation to the supply chain and the other manufacturing processes. Yeah, the basic aspect of smart manufacturing is three: automation, computation, networking, and cloud computing. So therefore, when we combine them together and work with them mutually, so therefore we can have a reliable system for the smart manufacturing. As you can see, this is a simple figure which gives us a clear picture about what the content of smart manufacturing, which starts from industry, the peoples, the internet, all other aspects, delivering machines and all other aspects in manufacturing and the technological industries. So therefore, for any system to have an efficient running, it must have some objectives. So the few objectives of the resilient smart manufacturing are as follows: is to have a sustainable innovations by using of state-of-the-art advanced automation and control. Like in some of industries, we use like robotics and advanced softwares. Like for the current trending, we are having like the launching of 5G by China and America. So these are some of the main objectives that we can use it to sustain such innovations. Also, another objective is that to utilize energy, manpower, cost, and other resources with an intended aim of satisfying consumers' needs without compromising the manufacturing process and causing disturbance to the environment. So therefore, when we implement smart manufacturing, like our environment will be in the safer part of the product. So we don't have much problem with also like air pollution, environmental degradations, and other problems in the environment. So these are some objectives of smart manufacturing. Like we can see, yeah, someone from home, he can use the idea of smart manufacturing to order his goods from manufacturer and even check it is quality, quantity, and even all other features that he can be need to assess it, he can use it using this very innovation in technology. And also another important objectives of this resilience smart manufacturing is that the system will remain capable of considering so many factors such as political, economic, social demand of the society. So therefore, when we implement it, it will give us a hint that we can politically, economically, and socially rule like industry in the world. Okay, for our current situation, like in this current situation, we're having corona pandemic. If we say that the smart manufacturing has been implemented for so long, so therefore we will not have like sudden interruption in supply chain manufacturing. So therefore, we only use machines for delivering manufacturing and the services of goods to the various consumers. Yeah. And all these objectives can be achieved through the ongoing competition and initiation of innovation ideas of world-leading technologies, companies in developed and developing countries such as US, in China, and India. I think in India, there is only one company that implement this smart manufacturing, like that is Tata Motors. They are the main competitors in India that they are trying to implement smart manufacturing in their automation and other processes of manufacturing. So let me highlight some basic idea about resilient smart manufacturing. Over the years, yes, confirm, over the years, production exists a very long ago, from the Stone Age down to current digital world we have. Like we are in the 18th century. British industrial revolution was successful because it was empowered, it is capable of British Empire with it is utilizing steam engine and iron. So therefore, most of the industrial revolution uses the existing factors. Like for the British, they use steam engine and iron to succeed in their own revolution. While in this revolution, the leaders in this revolution, like US and China, they use like 5G, cloud computing, Internet of Things, and artificial intelligences to lead the global competitions in the smart manufacturing. And another technological advantage of smart manufacturing and also an idea behind it is that using smart manufacturing, we are able to detect both visible and non-visible challenges that we may encounter during manufacturing. Before we are only after the visible challenges, like we are after when our machineries or our system is not working in an efficient manner, like it is producing less product, so we can detect and ensure that we amend it. But the invisible part of it, like wears and tears of the machineries, we can't detect it. So, but thereby implementing this resilience smart manufacturing, we can be able to detect such defect and come up with fruitful results. So therefore, we can have a system resilience. For any system, we can have like the main factor that are driving such system. Like in smart manufacturing, we are having some key drivers. The key drivers in smart manufacturing are strong wireless connection, data analysis, generative designs, computer-aided design, and the advanced robotics. So these are the components that are driving that are the key drivers in driving the resilient smart manufacturing. Apart from these key drivers, there are other factors that we need to consider, such as artificial intelligences, because in artificial intelligences is what give us the breakthrough to the development of smart manufacturing due to its multi-purpose characteristic of storing, computing, sharing huge data, which give us technological manufacturer ability to improve level of production and increase their competitiveness. So therefore, we can. So I said there are some basic key drivers to the resilience manufacturing. So the basic drivers in smart manufacturing are sensors, strong wireless connection, data analysis, generative design, computer-aided design, and advanced robotic. And also other supporting key drivers are artificial intelligences, Internet of Things, cloud computing, and machine learning. Like the first part are the hardwares, like the hardwares we use, all like components we use, while the second part they are the like mostly the softwares. Like when we take like the internet, the artificial intelligence is like it gives breakthrough to the development of smart manufacturing because it has a multi-purpose characteristics of capable storing, computing, sharing use data, which gives technological manufacturer ability to improve level of production and increase their competitiveness. Also, Internet of Things is another key driver which will give like an interruption, like an integration of computer devices, mechanical digital machines with different unique identifier for them to work in as a system, like in order to avoid human to computer interaction. Mostly we use cloud computing for that huge data storage. Yeah. Yeah, this is what we use as the data storage of Internet of Things. Like another key driver is machine learning. In machine learning also, it's a question, like we use it for solving like complex equations in our resilience manufacturing processes. Therefore, another aspect is basic requirement for resilience manufacturing to succeed. We must have a cheaper, reliable, accessible, and robust system for collecting, processing, retrieving, and management of data in smart manufacturing. So all our manufacturing processes must have this kind of features. We must have a cheaper, reliable, accessible, and robust system. So therefore, we can have a very resilient smart manufacturer. Another fact or requirement is that the system must be sustained and optimized to the supply chain completely in the system also. And another requirement is that we must have an established, organized, and well-integrated education to which the smart industry can rely on. So therefore, because the system is already at like embryonic stage, so therefore we must implement a well-integrated educational system from like higher education, from lower education to the higher educational level. So therefore we can mold some people. Therefore they will focus on the system of implementing the smart manufacturing. Yeah. By the way, there are so many benefits that we can gain from the smart manufacturing, especially in supply chain processes, because mostly manufacturing it deals with supply chain. So all the parties like the supplier, the manufacturer, and the consumer will benefit immensely when the smart manufacturing a resilient system was implemented. And the first one is the supplier. The supplier might use the opportunity using smart manufacturing to optimize the user requirement, especially in environment where there is limited medium to which he can interact with the end user directly. Like a supplier may advertise his product, the product he obtained from the manufacturer. So therefore, a seller from a consumer from a different region in the world may see that product and show interest in it in order to buy it. Also, the manufacturer may implement smart manufacturing in production, will lead to a sustained and valuable product that can be traced, tracked, and apply simulation process to detect possible variation in the supply chain. Maybe he may use like a target target customers to a particular location in the world to see that it is their needs. So therefore, we can supply a particular product to them. And also a certain location in the world, they may require different category of material. So therefore, we can use that smart manufacturing to satisfy their need. And lastly, to whom we all need our product to be satisfied by him is the end user. The end user is the basic person that we are always targeting on him for him to satisfy us with our product. So therefore, the end user may use that smart manufacturing resilience to have an assurance of quality and the timely delivered of the product. Maybe he issued some material from India, maybe to Australia, and the manufacturer may tell him that the system they reach him is also dead. So therefore, he can track the movement of that material despite all the challenges we are having. And also, he may use that idea to send a feedback and the suggestion to the parties, like to supply the manufacturer, whether to improve the kind of product they are offering to their customers using that smart manufacturing. Okay, by the way, all the system we are having, it must have some few challenges to confirm. Also, smart manufacturing has some few challenges. The main challenges are no evidence for any reliable, dependable parts for the manufacturers like technological industry to embrace the innovation in manufacturing. So many manufacturing industry, they are not interested in implementing the smart manufacturing because of the unavailable skill, manpower, and the funding. And the second challenge is complex and wider range variability in data to be processed by the machine. Maybe the data you may need to use in particular product may be different. So therefore, it needs another program. So therefore, this complex and the variability is very, very challenging to the process of smart manufacturing. Another challenge is that no system that can be used to detect machine failure, which may lead to output with high possible errors. No system would have like 100% efficiency without error again. Then some complex industrial process may be impossible for machine to handle without human intervention, like delivering lectures in the class. Sometimes the instructor may need to be there for a successful delivery of the lecture. I am just certain example with academia. So therefore, there are so many certain complex processes which human must intervene. But in smart manufacturing, we are trying to avoid human intervention or human computer intervention. So these are some of the challenges. Other few challenges are data management and the life challenge, data processing, data protection and the security challenge. Like this data protection and the security challenge is one of the most problematic aspect of smart manufacturing, where hackers may use their own domain to hack the system and use it in other way around. And data visualization challenge. These are some few challenges that we can encounter during implementation of smart manufacturing. Then conclusion to these discussions, for the implementation of smart manufacturing